Hello students, welcome to Creata Classes. I am Gurmeet Singh and also welcome to the complete series on chapter circle for class 10 students. We will cover all these lectures in this series using the power of visualization and animation. Specifically in this lecture, we will cover all the concept of chapter 10 circle. We will cover everything about the circle and the tangent. The link to all the other lectures are given in the description. Check it out. So without taking any further time, let's start with this lecture. Best of luck. You must have done the circles in the previous class, but again we will do the introduction. It will help in building the basic foundation. So this is a circle. The boundary of the circle is called the circumference, the perimeter or the boundary. This is the circumference. The boundary or the circumference of the circle is composed of infinite number of points. These all are the points. All these points join or club to form the circle. This is the center. The distance from center to any of the point on the circumference of the circle is called the radius. So these all are the radius, and radius is constant in a circle. So all these radius will be equal to each other. That is, the distance from center to any of the point on the circumference is equal. That is the radius, which is fixed for a circle. And twice of radius is the diameter. This is the radius and this is the diameter. So we can say diameter is formed by joining any 2 points on the circumference of the circle which passes through the center of the circle. So this complete is the diameter. And if we join any 2 points on the circumference of the circle, it will form the chord. So this is the chord, this is the chord, all these are the chord. And the chord which passes through the center of the circle is the diameter. So diameter is also a type of chord, or we can say the longest chord of a circle is the diameter. So let's move to the secant. Secant is a line segment which intersects the circle at any 2 points. So this is the secant. This can also be the secant, any line segment which is intersecting the circle at any 2 points. Secant is basically dividing the circle into 2 parts, which are known as segment. The small one is the minor segment, big one is the major segment. And this portion is known as arc. Small is minor arc and big one is the major arc. Further move to sector. This is a sector, the pizza slice portion. Take the 2 radius and the arc, it will form the minor sector. This is the minor sector and this big one is the major sector. Further, this is the tangent, which is a line segment which touch the circle at any of the 1 point. So this is the tangent. And this chapter will be all about the tangent. What is the property, the theorem, everything related to the tangent. We have just done the basic introduction to the circle, what actually the circle is. So let's take down the tangent in detail. Firstly, let's understand the case of circle and a line segment. If we take a circle and a line segment which are not intersecting, then this will be called the non-intersecting case. The line is separate, circle is separate, both are not intersecting. Okay. Further, let's take the line segment inside the circle. This case is called the secant. We have just seen secant is a line segment which passes through the circle, intersecting the circle at 2 points. So here, this secant is intersecting the circle at point A and B. Got it? Let's move further. Let's move the secant such that it just touches the circumference of the circle at only 1 point. This will be called the tangent. Tangent is touching the circle at only 1 point. Secant is touching the circle at 2 points. And the first case non-intersecting, in which the line and the circle are not intersecting with each other. Just observe this tangent in very detail. If we start rotating the tangent in clockwise direction, it will start intersecting with the circle at 2 points, forming the secant. And if we rotate it to the left hand side or the anti-clockwise, it will form the tangent. And if you try to again rotate it anti-clockwise, it will again intersect the circle at 2 points. That is, it will form the secant. So for this point A, only one tangent will be possible. If you try to rotate this line in clockwise or anti-clockwise direction, the tangent will be dissolved and secant will be formed. So every point on the circle can have only one tangent. Suppose take a point B and let's draw the tangent. This is a tangent touching the circle at only 1 point. We cannot have more than one tangent at a point. If we try to draw any other line at the point B, it will form the secant. It will not remain the tangent. So every point on the circle will have only one tangent. This is important. So this is the tangent. This is very, very important, and it will be used in your exam as well as in the future competitive exam. This is the basics of the tangent and you should know it. Moving further, let's understand some terms related to the tangent. The point of contact. Point of contact is the point at which the given tangent touches the circle. This point at which the tangent is touching the circle is the point of contact. Here the point P is the point of contact. We can take a real life example of tangent. This is a bicycle and the wheels of the bicycle are rotating on the ground. So at any given point, the ground, which is a flat surface, will act as a tangent to the wheel. Here this wheel is a circle and the ground is a tangent. And this point at which it is touching the wheel is called the point of contact. Just a practical example of what the tangent are. You can also apply the concept of tangent in a pulley. This is a pulley which are having a rope. So this rope is also acting as a tangent. If we try to form a line segment out of the rope and if we extend it, this is a tangent. Just to give you the practical sense of the tangents. Why tangents are important? When you go in the higher class, you do the physics or you do the force and the dynamics. In those cases, the direction of the forces will act as a tangent. So just to give you the practical glimpse of the tangents, let's move further. Let's move to the next concept. The tangent at any point on the circle is perpendicular to the radius through the point of contact. This is a concept, also the theorem 10.1. We will not do the proof in this lecture. In this lecture, we will cover the understanding of this chapter. In the next lecture, we will cover the theorem. So the concept is that we are having a circle and we are having a tangent. And if we draw the radius from this point of contact, what is radius? Radius is a line segment joining the center point with any of the point on the circumference of a circle. So this is a circumference and this circumference is having the point P. So this line segment joining the point P with the center is the radius. The concept is that this radius and this tangent will always be perpendicular to each other. They will form the 90-degree angle. You can take any point on this circle. Let's take this point as point A, and if we draw the tangent from this point, we can only form one tangent. We have just seen in the previous example. So we can have only one tangent across this point A, and we can also form only one radius from this point. So this is the radius joining the center. This tangent and this radius will form the 90-degree angle. Similarly, you can take any point on this circumference and you can draw the tangent from that point and also the radius toward the center. Both of this tangent and the radius will form the 90-degree angle. This concept will be used many times in solving the question. The tangent will be given, the radius will be given, or any triangle can be given. You can form a triangle out of the tangent, radius and the third line. So you have to use your imagination how you can solve the question based on this concept. If we take any triangle based on this data, that triangle will be a right angle triangle. That is, one of the angle is a 90-degree angle. So you can apply this concept, also the concept of the right angle triangle, that is Pythagoras theorem, and you can solve the question. Some basic tips on how to solve the question, but when we actually solve the actual questions, there you will get the actual idea how to approach and solve the question. Students, information for you. Download the PDF of the formula and concept list for this chapter. The link is given in the description. There you will also find the similar PDF of the concept and formula list for other chapters too, especially for the class 10 student. So check the link in the description, and now back to the lecture. Let's move to the next concept and see the number of tangents from a given point. In this concept, we will try to understand how many tangents we can form from a given point to a given circle. We will check out the three cases. In the first case, the point is inside the circle. In the second case, the point is on the circle. And in the third case, the point is outside the circle. Let's check out the first case in which the point P is inside the given circle. Let's see how many tangents we can form from this point P. If you observe, we cannot form any tangent from this point P. Tangent is a line segment which touches the circle at only one point. Here point P is inside the circle. Whatever line segment you draw from the point P, all will intersect the circle at 2 points. So all these line segments are the secant. None of the line segment is the tangent. So we can conclude that from a point inside the circle, no tangent can be formed. Got it? Let's move to the second case. in which we are having a point P on the circumference of the circle. So let's see how many tangent we can form. The same concept we have just covered, we can only form one tangent from a point given on the circumference of the circle. A single point on the circumference of a circle will produce only one tangent. All the other line segments from this point P will be secant to the circle. Only one tangent is possible from the point on the circumference of the circle. Got it? The same concept we have just covered while giving the introduction to the tangent. Let's move to the case number 3, in which we are having a point P outside the circle. This is very important concept, and mainly most of the questions are based on this concept. So pay your full attention please. Let's draw the line segment from this point P toward the circle. So all these line segments are originating from the point P. If you observe, and the important concept is that we can have only two tangents from the point P which is external to the circle. All the other line segments are not the tangent. These line segments are the secant, these two line segments are the tangent, and all the other line segments are the non-intersecting line segment. So we can have only two tangents from the point external to the circle. So here the above tangent is touching the circle at point T1 and the below tangent is touching the circle at point T2. Got it? The point which is outside the circle will form two tangents toward the given circle. The point inside the circle will not form any tangent, zero tangent. The point on the circumference of the circle will produce only one tangent. And the point outside will form total two tangent, 0, 1, 2. Further, one more important term is there which is known as the length of the tangent. Length of the tangent is the distance between the point at which the tangent is touching the circle and the given external point. Here the given point is point P from which the tangent is originating, and it is touching the circle at point T1 and T2. So we can say PT1 is the length of the tangent and also PT2 is also the length of the tangent. The concept is that both of this length of the tangent, that is PT1 and PT2, will be equal to each other. This is also the theorem, that is theorem 10.2. The length of the tangents drawn from an external point to a circle are equal. If we are having any point which is outside the circle, external to the circle, we can draw two tangents toward that circle and both of the tangent will be equal to each other. Equal means the distance between the given point P, which is the external point, and the point of contact at the circle. That distance will be equal in both the tangent. And based on this concept, we will solve many questions. So two important concepts we have done. The first concept we have done is the tangent and the radius will form a 90-degree angle. And the second concept, the important concept we have done is that a point which is external to circle will produce two tangents and length of both the tangents will be equal to each other. These are the two important concepts, and these two important concepts will be used in solving many questions. Do not note it down, just go to the description and download the formula and the concept list. That will be really helpful. And for proof of both the theorem, check out the link in the description. We have a separate video for the same. So students, we have done with this lecture. If you have enjoyed the lecture, like and subscribe to our YouTube channel. And also share this lecture with the class 10 student and your friends. Also check our YouTube channel, the playlist section, for the similar kind of video for the complete series on other chapters for the class 10 student. So best of luck for the exam you are preparing for, and bye for now and have a great day. Best of luck.